0.28814, this is the probability. Now, we have to add with this probabilities with this. So, now this is we can find by first of all we first find z less than equal to minus 2. So, this probability we can find from the table. So, this table here you can see minus 2, this is 0.02275, 0.022. So, here minus 2, 0.02275. So, this value here we can find 0.02275, 0.02275. So, now this area same as, so this area actually this area same as this area. Now, we want to add with this probability with this probability. So, this probability, what will be the probability? This probability will be nothing but probability that 0 greater than equal to z. So, this probability is same as z is greater than equal to 2. So, we want first we have to find the probability less than equal to 2. This probability will be nothing but half minus, because total probability is half minus of probability that z greater than equal to 2. So, this is nothing but 0.5 minus z greater than equal to 2 is same as probability that z less than equal to minus 2. This is nothing but 0.02275. So, this is how we can compute. We have to just subtract it 5, then 2, then 7, then 7, and then this is nothing but 4. So, 0.47725. So, this probability we found. Now, finally, how we will find? We find that minus 0.8 less than equal to z less than equal to 2. So, this will be nothing but addition of this probability. So, this is nothing but probability that minus 0.8 less than equal to z less than equal to 0 plus probability that 0 less than equal to z less than equal to 2. So, this probability addition of this 0.28814 plus 0.47725. So, if you add these two probability, then we will get that. So, this is 9, then this is 9 3, and then this is 5, this is 6, and then this is 7. So, 0.76539. So, please check that this calculation and computation are correct, because just we are doing computation. So, because there may be some mistakes. So, you can see that if there is any numerically is there any mistake here, but the concept is how to find the probability here. So, now second question is that, so what is the second question? Second question is that, so this probability we have find out, x less than equal to 26 less than equal to 46. So, this probability how we can, what is the final value? This is 0.76539, 0.76539. Now, next we have to find what is the probability that x greater than equal to 45. So, let us see that what is x greater than equal to 45, x greater than equal to 45. So, now we have to take this transformation similar. So, it is x is 35. So, we have to take the transformation x minus 30 by 5. So, then this is nothing but probability that x minus 30 by 5. So, this is the mean it was given, and this is greater than equal to 45 minus 30 by 5, 45 minus 30 by 5. So, this is the variable standard normal z. This is greater than equal to 45 minus 30 is 15, 15 by 5 3. So, this is nothing but z greater than equal to 3. So, now in this curve standard normal variate. So, this is 1 2 3, this is minus 1 minus 2 minus 3. So, now z greater than equal to 3 it is asked. So, this is same as z less than equal to minus 3. So, this is same as by symmetry z less than equal to minus 3. So, z get less than equal to minus 3 we will find from the table, z less than equal to minus 3 here, this is 0.00135. So, this value will be, so you can see that here minus 3, this value will be 0.00135. So, hopefully you have understanding that you are following that how we can use this table for standard normal random variate, and we can compute the probability of any normal distribution with having any general mean and variance. So, this is how, what is this 0. Z less than equal to minus 3, this is nothing but 0.00135. So, this value will be nothing but 0.00135. So, that is the question, x greater than equal to 445, this is nothing but 0.00135. Now, the next problem we will discuss what is the probability. So, let us see what is this is the. So, now we have to find what is the probability x greater than 30, mod of x greater than 30 is greater than 5. So, that we have to find out. So, probability that mod of x greater than 30 greater than 5. So, now how we can find? So, mod of, so it is question is that probability x greater than 5 mod greater than 5, mod of x greater than 30. So, this is same as, so we can say how we can compute it, this is same as, okay, basically it is a mod of this. So, if you divide by 5, so probability that what is the transformation here, x z is x minus 30 by 5. So, basically if you take x minus 30 divided by 5 here, if you take the mod of this, this is same as, this is if I divided by 5 1. Now, the x minus 30 by 5 is nothing but mod z greater than 1, where z is a normal 0 1 variable. Now, mod z greater than 1, it is same as 1 minus probability that mod z less than equal to 1. So, mod z less than equal to 1, how we can find? See, or we can find, see, first let us consider, check this graph here, then it will be more clear to understand. So, mod z greater than 1, it is nothing but basically suppose 1 minute. So, this is, suppose this is 1, this is 2, this is 3, this is 3, this is 1, this is 2, this is 3. So, mod z greater than 1 means we are talking about this is the greater than 1 it is asking. So, z can be greater than 1 this area, or z can be less than 1 minus 1. So, this is minus 1, minus 2, minus 3. So, mod z greater than 1 means probability that z is greater than 1 plus probability that z is less than minus 1, or you can keep equality also, no problem, because it is a continuous random variable. Now, by symmetry, probability that z is less than minus 1 is same as probability that z is greater than 1. So, we can write this is 2 into probability z is less than minus 1, since by symmetry probability that z is less than minus 1 is equal to probability that z is greater than 1. So, that is why 2 into probability of z minus 1. So, this is nothing but 2 into phi, phi is the cumulative distribution function of the standard normal variate. So, it is 2 into phi of minus 1. So, this phi of minus 1, this value we can find from the table. So, z less than minus 1. So, this is from the table you can find here, minus 1 is here, this value is nothing but, this is minus 1, this value is nothing but 0.15866. So, minus 0.15866. So, here you can see this probability 0.15. So, just I remember 0.15866, 0.15866. So, this is where it is 0.152 into 0.15866. So, just you have to multiply it 2 . So, this is nothing but 0.31732. So, this is the probability we need to calculate. So, then we found this. So, we just discussed 2 example. So, this is very similar type of example, but we have learned how to compute these probabilities for using the normal distribution or with any mean and variances. So, we can discuss some more examples also. Let us discuss another numerical example. Suppose the marks obtained by a number of students, the marks obtained by a number of students by a number of students for a certain subject certain subject are assumed to be approximately normally distributed, with mean 65, with mean mu is equal to 65, and standard deviation sigma is equal to mean is equal to 65 and standard deviation is 5, actually sigma is 5, it is given. If 3 students are taken at random, if 3 students are taken at random from this set, what is the probability that exactly two of them will have marks over 70. So, this is the question here. The marks obtained by a number of students for a certain subject are assumed to be approximately normally distributed with mean mu is equal to 65 and standard deviation sigma is equal to 5. If 3 students are taken at random from this set, what is the probability that exactly 2 of them will have marks over 70? See that here we have to use not only normal distribution, also the binomial distribution we have to use, because this last part, it is like, suppose you know that probability that x is the random variable marks obtained by the students, and then x it is given like normally distributed, mean is 65 and variance is 5 square 25. Now, p is the probability that the any student will be marks obtained can be marks is greater than 70, p. Now, it is asked the question that why out of 3 students taken at random, y is the taken at random from this set, what is the probability that exactly 2. So, y is a binomial distribution, this total number of students here 3 it is taken, and p is this probability p. This p we have to find. Then the question is exactly 2. What is the probability that out of 3, what is the probability that y is equal to 2, that 2 will be exactly over 70. So, this probability will be 3c2 p to the power of t 1 minus p to the power of 3 minus 2. This is the probability we discussed in the binomial distribution. So, this probability we have to compute. So, for computing this probability, first we have to find what is the value of p. So, let us find out this values of p first. So, this p can be found, p is equal to probability that x greater than 70, So, this is nothing but which is equal to now because x has mean, it is given that x has the mean 65 and variance 5 square, sigma standard deviation is 5. So, then z is equal to x minus 65 by 5, it will be normal 0 1. So, we will use the similar concept here. So, p is equal to probability that x greater than 70, which is equal to probability that x is nothing x minus 65 by 5, which will be if x greater than 70, then x minus 65 by 5 will be greater than 70 minus 65 by 5, which is equal to probability that z is greater than, now here it is 65, 70 minus 65 by 5, this is equal to 1. So, now that several times we did this. So, because this is 1, this is 2, 3 like this, similarly minus 1, minus 2, minus 3. Now, z greater than minus 1 means it is asked what is the probability here. Now, this is same as by symmetry this probability z is less than minus 1. So, this is probability of z is less than minus 1, because why you are doing this negative number, because from the table we can find this value. So, probability that z less than minus 1, it is given minus 1 is 0.15866, 0.15866. So, this value we can find here 0.15866. So, 0.15, so here nothing but 0.15866. So, then we know this probability P. Now, we have to find what will be the probability that it is asked that probability of y is equal to 2. Exactly 2 students have got the marks greater than 70 out of 3 students. So, this is nothing but probability that y is equal to 2, this is 3C2 0.15866 whole to the power 0.15866 whole to the power square, and 1 minus of 0.15866 whole to the power of 15866 whole to the power of 3 minus 2, this is 1. Now, you have to, this 3C2 is nothing but 3, this is nothing but 0.15866 whole square, and then this also you have to calculate. Here we need one calculator to calculate this. So, I can say you what is the value, it is already computed. So, this is nothing but 0.06357. So, this is nothing but 0.06 0.06357. So, this is the value. Please check that this may be some decimal places, it may be approximated. So, this value, so that you can check it. So, now we have already learned that some of the discrete distribution function or some of the important discrete distribution function. There are many other important distribution function other than whatever discussed here. Just some of the important distribution function like Bernoulli distribution, binomial distribution, these are all frequently used, and this and also Poisson distribution function we discussed. Some more other distribution like continuous like hypergeometric distribution function, geometric distribution function, negative binomial distribution function we did not discuss here. So, if we get time, then we will discuss in the later part. And now, the continuous distribution we discussed uniform distribution function, exponential distribution function, gamma distribution function, and now we have discussed the normal distribution function. Also, we have discussed what are the use of these distribution functions, what are the application of this distribution function. Now, we will discuss some different topic. We completed the univariate distribution most of the part. Also, we need to discuss the conditional distributions, how a random variable conditional probability we have discussed, but how conditional distribution will be defined for a given event, we can discuss that. Suppose we have a distribution function, a cumulative distribution function of a random variable x. Now, we want to find a conditional cumulative distribution function f x given a event b. So, b is a given event, it is given. So, now how we can find a random variable x given b is defined by f x x. So, let x be a random variable with the cumulative distribution function so, it says C.D.F f x x. So, this is nothing but probability x less than equal to x. The conditional distribution, so it is defined at the conditional cumulative distribution function of a random variable x given b. The conditional C.D.F given b is conditional C.D.F given b is defined as so how it is defined. So, f x of x, this notation is x given b. So, here you can see that this notation only it is given f x of x given b. So, we can, because this function and that function will be different. So, we can name like x given b. So, this is nothing but probability that x less than equal to x given a event b, if b is any event. So, now this is the one event a given b can be defined as x less than equal to x intersection b by probability of b, provided here it is assumed that probability of b is not equal to 0. Now, if x is a discrete random variable, then we have to define the conditional probability mass function. So, if x is a discrete random variable, if x is a discrete random variable, the conditional probability mass function of x is given by Px of xk given b. So, we can write this function because we already have Px is a probability mass function of x, this probability of conditional probability mass function we can given x given b. So, this is nothing but probability that x is equal to xk intersection b by probability of b, whenever b probability of b is not equal to 0. So, conditional probability mass function is given by defined by this. We will discuss some numerical example to make it how we can compute this to see this. Now, how we can define the whenever x is continuous random variable, then we cannot define this in this way, because for a continuous random variable probability at a point x is equal to x, this probability is 0. So, in that case we cannot, so how we can define? So, if x is a continuous random variable, if x is a continuous random variable, the conditional probability density function, conditional P.D.F of x given a event b is defined as, so this is x given b, because it is a conditional probability density function, it is nothing but the derivative of the cumulative distribution function, conditional cumulative distribution function. So, conditional cumulative distribution function, it is assumed that it is differentiable for continuous random variable, and this derivative is defined as for the conditional probability density function. So, this f of x given b, it is defined here. So, this will first find, then you will take the derivative, then you can find the conditional probability density function of a random variable for any x belongs to the real number. So, how it can be utilized? Let us do some numerical example. So, then we can have some idea how it can be used. So, let us consider one numerical example. Let us first discuss this continuous cases, then we will discuss this discrete case. Let x be an exponential random variable with parameter lambda greater than 0 and b is given this 1 infinity. Find the conditional probability density function of x given b. So, how we can do that? So, let x be an exponential random variable. So, for finding this conditional probability density function, first you have to find the cumulative distribution function. For discrete case, it is not required, it is directly we can find the probability mass function also, but in this case we have to first find the cumulative distribution function. So, discrete case also we will discuss, because a density function for continuous cases we need to first find the cumulative distribution function. So, let us do that. So, it is given that